Welcome. What I want to do quickly here is to go over the unit circle, which we began presenting on Monday. And we kind of ran out of time near the end, but I wanted to give you a full sort of presentation here that you can refer back to. You will be asked to fill in the unit circle with all of the required parts of it. And I started out here with the unit circle with the degrees marked in. Once you've sort of memorized the first batch here, these will give you, you can use those same values in the other parts of the circle when we talk about the coordinates. You'll notice here that I have some in blue and then some in red. That's because they're divided up into certain ways we can count here, which follow a pattern, especially when we're getting to use radian measurements. So once we've put in all the degrees and then the radians, then we can focus on the coordinates, okay, which will be the ordered pairs here. This is a unit circle, so for each one of these, we want to have the ordered pair that goes with that degree. Okay, so let's start with the reds, which are our 45 degree sort of increments here as we go. And I'm going to mark those out here because we have 45 degrees, which is half of 90. So 90 is also a part of the 45 degrees, but you'll see it's also in blue. It can also be a part of the 30, 60, 90 group. So I'm going to just mark these out here. You'll notice that the 45 degrees, oops, sorry, that goes right here, cuts the arc length in half. I'll erase that. So, for example, 45 here, you can see that the distance from here to here is approximately the same as it is from here to here. And that's because the degree measurement is cutting this in half, so we say it's bisecting the arc. And that's true. Oops, I put the wrong spot here. That's true over here. It's true here. And it's true here. So literally we're going in 45s. We have 0, then we have 45, and then we have 90. If you add 45 to 90, you're at 135. If you add 45 to 135, you're at you're at 180. And then add 45 to that, you're at 225. Add 45 to that, you're at 270. And then 315, and then 0. So we're counting in 45s. If you'll notice that if we take pi as being, so we notice, let's count these out here. We have 1, 2, 3, 4, 5, 6, 7, and then 8. 0 and 360. We're just going to rename those. Those are coterminal angles. They're both just signifying being right here at 1, 0. So there's 8 different 45 degree angles, right? And if pi is here, then we've divided it up 4 ways. 1, 2, 3, 4. And so pi over 4, pi being 180, is my radian symbol for 45 degrees, right? So this all becomes manipulating that pi over 4. So going back to marking this with the red, this is my first radian measurement, pi over 4. Pi over 4, and then that's 1 pi over 4, and up here we have 2 pi over 4s, which reduces down to, with 2 going into 4, to pi over 2. We always want to express these in their lowest form. But in terms of us kind of looking at using pi over 4, this is the second pi over 4. This would be the third pi over 4, which is what we actually call this, 3 pi over 4. That doesn't reduce. And when we add one more pi over 4, that gives me 4 pi over 4, which, of course, cancels down and simplifies. Whoops. My iPad likes to put in extra lines and things like that. I'm just going to erase these really quick. The ones I can, at least, without destroying the other ones. Let me pause this. So 4 pi over 4 reduces down to pi. And then we have 5 pi over 4. That doesn't reduce down, so we just leave that as 5 pi over 4. And then we have 6 pi over 4, which if we take out the 2's, leaves us with 3 pi over 2. And then one more, this is 6 pi over 4, so this is 7 pi over 4. That ends up not being needed to reduce. And you'll notice 7 pi over 4 is 1 away from a number that 4 will go into, 8, which is our 8 pi over 4 is the last one here, the last pi over 4. This reduces down to 4 goes into 8 two times, so 2 pi. Great. So now we have our 45s mixed out. I don't need these extras here. I'm putting those simply as, so you can see me reducing them down and keeping the unit circle kind of tight there. All right. So that is our pi over 4s. Now I'm going to actually just go ahead as we're doing this and talk about and look at what values we put for the coordinates for these points before I move on to the blues. And while I'm doing this, I'm going to go ahead and erase these two. So I want to look at what coordinates we have at these various points. I'm going to leave them in red just so we have clarity there. And make sure I'm putting these in the right place. It gets a little confusing about here they're under and here they're over on the top and on the bottom. That's where I was getting a little confused with their where we're labeling them. So just be aware of that. This, is going to the red point there. And I think that's true for the lower halves here. Yeah, the lower halves have them under. Let's see, here it's above. Here it's above. And here, and the upper parts have them. So the upper parts have them above the line. And the on the upper half of the circle, they're below the line that they go to. So be aware of that as you're doing this. So let's talk about their coordinates. If you look at the place, you can almost visualize it here. And I'm not going to write on here, but where they hit the x-axis here, and then where they hit the y-axis here. You'll notice that it's more than half. It's at greater than the 1/2 position. And it's closer to the ones, right? And if you actually were to visualize this out, because it's hitting the halfway point, we know that the y value and the x value are going to be the same value. This actually gives us and I'm going to draw over here, an isosceles right triangle where the two legs are the same distance. These may not be exactly the same distance, but I tried. So with the radius being 1, we can see that if these two have to be equal, so for example, if we have it equal to 1, and let's say that because they're equal, I'm going to use the same variable, right? X is representing their length, and if their length is the same, then I want to use the same variable, right? And so I can add these two together now. That gives me 2x squared equal to 1. And then if we divide both sides by 2, the 2 cancels out over here, and I have x squared is equal to 1/2. And then taking the square root of both sides, that gives me x is equal to 1. The square root of 1 is 1, but we still have this square root 2 on the bottom. And so to get rid of it, we rationalize it, right? We multiply the top and the bottom by the square root of 2. And so x is equal to the square root of 2 over root of 2 times root of 2 just gives me 2. This becomes the x and the y coordinate value. It's on the middle spot here, and so it makes the x and the y be at the same value, right? That gives us a isosceles triangle. And I put 3 there. I don't know why I put 3 there. I was saying 2, and I'm writing 3. Let's go ahead and put that in there. Okay. Now, the only thing that's going to be different, over here you can see it's the same thing, right? It's hitting the same point, and it's hitting the same point x-wise all around this circle. In fact, this gives me a square. And so these are all going to have the same coordinates. The only difference here is the x value goes in a negative direction, right? Where x is going in a negative direction, y is still going in a positive. So we just have to change the signs. This is negative root 2 over 2 and positive root 2 over 2. And down in the third quadrant, they're both negative. Negative root 2 over 2 and negative root 2 over 2. And then over here in the fourth quadrant, it's positive x, so root 2 over 2 over negative root 2 over 2. With that, and actually we could have done this in the first place, let's look at the points where we hit the at the 90-degree angles there. Here, in my first point, this is at 1, and then it doesn't go up or down on the y-axis, so it's 0. And once we go 90 degrees up to the top here, we're at 0 for x, positive 1 for y. Moving to the 180, we're at negative 1 for x and 0 for y. And down at the bottom, we're at 0 for x and negative 1 for y. You can see very nicely how these 45-degree angles intersect at these spots. Now let's take a look at the blues. Right? We had 0, 30, 60, 90, 120, 150, 180. And then, oops, we're missing one there. This would be 210. And then 240, 270, 300, 330, and 360. Basically, we're counting for each one of these, we are counting by 30s. And so, again, let's start with the first one, 30 degrees. If we can derive the radian measurement, again, using pi equals 180, to get 30, we would divide by 6, right? And so we would do the same here. This gives me 30. So we see that 30 degrees is equal to pi over 6 radians. That's my first mark here, just like we marked pi over 4. And then we're going to work with pi over 6s, just like I did with pi over 4s. With pi over 6, our next 30-degree angle, that's 2 pi over 6. And you can see that 2 reduces it down to pi over 3. So I'm going to put that in there, pi over 3. We can even look at the 90s, right? We have a 90 degree. That's 3 pi over 6s. So we had 2 pi over 6. Now we have 3 pi over 6. This also reduces down to pi over 2, which we already have written in there. Adding another 30 using 6, that's 4 pi over 6. Which reduces down to 2 pi over 3. So we'll put that reduced value in there. And then we go another 30 degrees. We are at, we had 4 pi over 3, so this is 5 pi over 3. That doesn't need to be reduced, so I'm going to put that in there, 5 pi over 3. And then if we add another 30, we're at 6 pi over 3, which of course, or 6 pi over 6, which is simply pi. We already have that written in there. Then we have one more pi over 6, so that's 7 pi over 6. That can't be reduced. That's this value right here. Add another 30. We're down here now. That's 8 pi over 6, which can be reduced down to 2 goes into both of those, 4 pi over 3. Add another, we're at 9 pi over 6. And 3 goes into both of those. That leaves me with 3 pi over 2, which we already have written in there. Add another 30. We're at not 9 pi over 6, but 10 pi over 6, which 2 can come out of that, making it 5 pi over 3. Another one, we're up here, another 30 degrees, another pi over 6. Now we have 11 pi over 6, which is just one short. You'll notice one short of 12 pi over 6, which reduces down to 2 pi. So 11 pi over 6 can't be reduced. We go ahead and put that right in there. I have all of the angles, radian and otherwise, labeled in there. And we have them reduced down. That's what our goal is. Now let's look at putting in the coordinate values at these places. I marked them all in blue. Yep. So just a quick review idea here of what we did. The reducing, yes, we have to reduce them down, but this was really about adding one more pi over 6 every time, and there's 12 places where we do it. We start out with 0, then we have 1 pi over 6, 2 pi over 6, which reduces down to pi over 3, 3 pi over 6, which reduces down to pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6. 6 pi over 6, of course, reduces down to pi. 7 pi over 6, we leave that. 8 pi over 6 reduces down to 4 pi over 3. This was, I'm at 4, okay. Yeah, that was 5 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6, 12 pi over 6. 6 goes into 12 2 times. So this is really about just counting and adding up to 12. There are 12 places where each time we're adding another 30 degrees or another pi over 6. Okay, so the other two values that we see when it comes to the 30 degree angles are 1/2 and root 3 over 2. And in your project for the unit circle, which will be due next Monday, we explore this idea here with the triangles, because these are all connected to triangles when we draw them in. For example, I could draw in one of the triangles here, right, leaving me with a 90 degree angle. And you can see in terms of the x and the y, that the x value is a lot closer to 1 than the y value. The y value hits at about the halfway mark. And with each of these, you can kind of use this as a visual way of remembering what goes where. Which one has the 1/2, which one has the root 3 over 2. Root 3 over 2 is the bigger number, because instead of 1, it has a root 3 on top. And root 3 is larger than 1. And so for this first one, the x value has the root 3 over 2, and the y value is at 1/2. Right? Larger, closer to 1 here, and then closer to the middle. Well, actually at the middle. So root 3 over 2 and 1/2. Once we get to 60, you see that same pattern, but it's switched up. The y value is actually higher than the x value. The x value now is falling at about the 1/2 spot. And so for 60 degrees, we have 1/2 first, our x, and then root 3 over 2 for the y. And over here, same thing. Notice it's at the same height, so it's still at root 3 over 2 for y, but the x now is negative. And that carries through in this quadrant. Here we still have a negative x, root 3 over 2, but the y value is still positive. And they switch spots. These are at parallel parts of the circle. Notice they're at the same height, 1/2, and they're at the same x, but with different signs. In the third quadrant, everything's negative, so we have negative root 3 over 2 and negative 1/2. And down here at what would be equivalent to the 60, right? We have the x being negative 1/2. They're just switching spots. Here we're just changing the signs, but the same numbers. Root 3 over 2 is now positive, and negative 1/2 is the y value. It's negative. Oops, I had those backwards. Sorry. We can see that it is at the same parallel, the same y. So we look toward the previous point there, the previous blue one, and it's positive 1/2 and negative root 3 over 2. So same pair. They're matching up here. And then up here, these are matching up. So it's the same numbers, just different signs. Root 3 over 2 is positive, and y is still negative 1/2. With this, I've filled out the unit circle, and this is what you want to be able to do. I would start, like I did, with your degree marks. As you go with the blank one, I've given you several blank ones to practice with. So start with the degrees, then go for the radians. This actually is 0 radians, so I'm going to go ahead and write that in there. Oops, don't put the degree symbol. I already have that there. So we have 0 radians, and we go ahead and we put all of those in. You could do the 45s first, and then go for the 30 degree, the ones that are divisible by 30 degrees. Put those in. Once you have those, as long as you know this pattern, when they match up, they're the same, right? This one is not the same as this one, but these are the same numbers, different signs, same numbers, different signs, same numbers, different signs, same numbers, different signs. And it's all a combination of 1/2 root 3 over 2, and then with the 45s, it's root 2 over 2. I hope this gives you a little strategy you can have in filling these in. You need to be able to fill these in quickly, within, like, I would say, at least a 10-minute mark. So practice with these if you can. There's a PDF version. If you have an electronic, like, pad or something, you can fill these in, erase it all, and start all over again. Doing them step by step there, counting by 12s, counting by 4s, those are all ways to strategize filling out the unit circle.